Sarah Martin, Speech 3. The sun, a great big flaming mass of helium, hydrogen, and a mismatch of metals. It rises in the east and sets in the west every day the Earth goes round. According to 9planets.org, the sun is 109 times bigger than the Earth. It creates 380 billion megawatts of energy per second. And by the time it reaches the Earth, it's only at 20% of what it originally was. Going through the atmosphere, it decreases even more, but it's just enough to sustain life. Humans have been trying to harness the power of the sun for centuries. And I'm going to tell you how we came about to trying to harness the solar power devices that we have today, and the applications for solar power used today. The history of trying to harness solar power actually goes back farther than you think. We can account for magnifying glasses and bronze mirrors being used as early 7th century BC devices, a crude sort of way to harness solar energy. The U.S. Department of Energy has compiled a lot of information about the history of solar power. The two main reasons that people back then, and still do today, use solar powers for warmth and light. Back then, they used mirrors to angle in the sun to light up buildings, and back then they also used to angle their civilizations all facing down towards the south so they could bring in the winter sun's ray to warm them up. But also, there is one rumor. Thor was the first person to create a solar collector. It was used to cook foods for his friend's safari trip down to Africa. But progress didn't pick up until 1876, when William Adams and Richard Day found out that selenium, the element selenium, actually produces an electrical charge when it's exposed to light. They did an experiment. They found out that it actually couldn't produce enough of a charge to power electrical devices, but they did prove that a solid could transfer or could make sunlight into energy. But since then, many scientists fiddled with ins and outs of solar power. The first solar cell capable of converting enough sunlight was created in 1954 at Bell's lab. It was only 4% efficient when they first started out, but when they they managed to get it up to 11% by the end of their experiment. But until then, it took 21 years later at the University of South Wales till they broke the 20th percent efficiency barrier, and it wasn't. And then even longer than till 1994. The Research Energy Lab, the Renewable Energy Research Lab, broke 30%. But even with those low percentages of efficiencies, there's still a lot of applications that we use it for today. Solar power wasn't available to us widespread commercially till around 2001 when Home Depot started selling solar panels for your roofs. But that's when houses were really starting to switch over because of the green energy movement sweeping the 2000s. And usage from 2003 jumped from 83 megawatts of solar energy to about 7,200 by 2012. But not all solar cells are made the same. Different companies have different elemental combinations that have different varying degrees of efficiency. The Special Materials Research and Technology Corporation made a cell tells us that a solar cell needs 6 main components. The first one is an encapsulator. Well, it encapsulates the actual solar cell. It's the outside part that it needs to protect the actual inside of the cell from all varying degrees of weather and allowing sunlight to come in, which most of the time companies prefer to use glass or plastic. And then the second main component that you need is the conductor, the grid lines that you usually see on solar panels. They have to be made of a conductive material, which is usually metal. And then below that is the anti-reflective surface, because if they don't have that, all the sunlight that hits the solar panels will just bounce off and nothing will get done. But where the science actually happens is with the two different silicons, the negative silicon panel and the positive silicon panel. And between that, the protons go down and they bounce around on the different valence electrons. And it's not complete until you use your back contact, which completes the circuit and transfers your energy to wherever you have it hooked up to. The demand for solar energy has gone up, but the turnaround profit for it isn't very much, and so companies are starting to cut corners. According to the New York Times, the first thing to usually go is the protective barrier on top. They usually make that out of a cheap plastic, and it wears away only after a few years. But sometimes it's a circuitry, but it's usually just random small things everywhere. But people really can't place where or who is making this happen, because most of the companies are protected underneath their confidentiality agreements, and so also because of the confidentiality agreements, we can't get any positive statistics or numbers about that. But there is improvement on the horizon. James Empach wrote an article about the California Institution of Technology. They are currently working on a solar cell that will broaden the energy intake. Instead of just intaking only the visible light spectrum, they are working to move beyond that. And they're hoping they'll have about a 50% efficiency capacity, which will put solar electricity way up there on the grid, make it more competitive. But even with the current efficiency rates being so low, applications are being used everywhere. We can now have portable solar panels. There are solar generators that you can take anywhere, like camping, or they're about this big, and there's one from Duracell that's about 200. It can charge your laptop, or you can watch TV. There's also, they have small, about 1 by 1 inch solar panels to charge your cell phone with. You can stick them to windows and sunlight will come in. And they take about 3 times as long than you would normally plug into an outlet, but you have a constant energy source wherever you need to go. It can go in your purse, it can go in your bag. It's also been put in bug-out bags for case government overthrow or what have you. It's because they're lightweight, they're reasonably priced, around $40 for a cell phone charger, and they can usually charge anything with a USB port. But going bigger than that, you can have roof panels, which can save on bills. The average American household uses about 940 kilowatts an hour a month, but just their Lowe's highest priced solar panel kit is about $20,000, and it produces about 9 kilowatt hours, which is about 570 to 200 kilowatt hours per month, which would cover most of your household needs from month to month. They even have lower price ones if you just want something, an option cheaper, or just partially save. But solar energy is a widely acceptable alternative to non-renewable energy such as coal or natural gas. But as humans, we've come a long way from magnifying glasses and mirrors and trying to harness the raw power of the sun. Even these past 10 years, solar power has come into our homes, and it can go with us now. Research continues underway, and maybe it'll be a competitive energy source for not only America, but for